Welcome to G Fun Facts Online. Every year in October and November, our planet glides through a vast trail of cosmic debris known as the Taurid Meteor stream. This passage gives us the Taurid Meteor shower, famous for its slow, incredibly bright Halloween fireballs. But a growing body of evidence suggests that hidden within this beautiful light show is something far more menacing: a concentrated swarm of Tunguska-sized objects, a celestial shooting gallery that Earth may have to navigate for centuries. This isn't a Hollywood movie plot about a single asteroid. It's a complex, recurring threat that forces us to look at meteor showers not just as a spectacle, but as a potential warning. To understand this threat, we must go back in time, perhaps 20,000 to 30,000 years, to the arrival of a colossal comet in our inner solar system. Astronomers believe the entire Taurid complex, which includes meteor showers, near-Earth asteroids, and the famous Comet Encke, is all that remains of this giant progenitor. Estimates suggest this parent body was staggering, anywhere from 40 to 100 kilometers in diameter. Its slow disintegration over millennia has littered its orbit with a vast river of debris. This idea was proposed in its modern form by astronomers Victor Klube and Bill Napier in the 1980s. Their theory of coherent catastrophism suggests that the breakup of such a giant comet doesn't lead to random, isolated impacts. Instead, it leads to periodic episodes of intense bombardment as Earth passes through denser clumps of the debris field. In this model, our solar system isn't a predictable clockwork, but a place subject to periodic convulsions, with the Taurid complex being the most immediate example. The most famous remnant of this breakup is Comet 2P/Encke. First spotted in 1786, its 3.3-year orbit is the shortest of any known bright comet, making it a frequent visitor. However, Comet Encke's nucleus is only about 5 kilometers wide. It's far too small and not active enough to have produced the sheer volume of material we see in the Taurid stream. This is a key piece of evidence for the giant comet hypothesis. Encke isn't the parent of the Taurids. It's more like the largest and most famous sibling, a major fragment from a much grander ancestral body. The Taurid stream itself is the largest structure of its kind in the inner solar system. It's so vast that Earth takes several weeks to travel through it each year. This is why the Taurid meteor shower lasts so long. We actually intersect this debris field twice. From September to December, the nighttime encounters create the northern and southern Taurids, peaking in early November. These are the fireballs we can see. The other intersection happens in June and July, producing the daytime beta Taurids. Because their radiant point is close to the Sun, we can't see them with the naked eye. They can only be detected by radar. What makes Taurid debris special is its composition. Unlike the fine dust that creates most meteor showers, the Taurids are made of heavier stuff, including pebbles and even boulder-sized objects. When these hit our atmosphere at over 100,000 kilometers per hour, they create spectacular fireballs, some brighter than the planet Venus, leaving behind persistent, smoky trails. But within this already massive stream lies the most threatening component: the Taurid resonant swarm. This is a denser clump of material within the broader stream, gravitationally shepherded by the giant planet Jupiter. The swarm's existence is a consequence of a 7-to-2 mean motion resonance with Jupiter. This means that for every 7 orbits an object in the swarm completes around the Sun, Jupiter completes exactly 2. This regular gravitational tug acts like a celestial shepherd, nudging the debris into a stable, concentrated bunch. It's like swirling a prospector's pan, where the heaviest gold particles collect in one spot. This resonance protects the swarm's larger members from spreading out over time. However, the same mechanism is less effective on smaller dust particles. The result is a swarm thought to be disproportionately rich in larger, meter-sized and multi-meter-sized objects, the very kind that can survive atmospheric entry and cause damage on the ground. Observational evidence for this swarm has been mounting. Astronomers noticed that years of predicted close encounters with the swarm's core, like 1988, 1995, and 2005, all had significant increases in fireball activity. During these swarm years, the percentage of Taurid meteors that become fireballs can jump from less than 1% to as high as 5%. We even have evidence from off-world. In 1975, seismic instruments left on the Moon by the Apollo missions recorded a cluster of impacts over a 5-day period, coinciding with Earth's passage through the Taurid stream. More recently, on November 7, 2005, NASA captured the first ever photo of a lunar impact flash, consistent with a Taurid meteoroid hitting the Moon's surface. These events strongly suggest a concentrated cluster of objects exists, just as the theory predicts. The Taurid swarm isn't just a theory. Many scientists believe it's the likely source of past impact events, some with devastating consequences. The most famous is the Tunguska event. On June 30, 1908, a massive explosion occurred over Siberia. The blast, equivalent to about 5 megatons of TNT, flattened over 2,000 square kilometers of forest, knocking down 80 million trees. No crater was ever found, meaning the object, likely a 50-meter wide fragment, exploded in an airburst several kilometers above the ground. The timing is what's highly suggestive. The event occurred during the peak of the Beta Taurids, the daytime shower from the Taurid stream. The object's trajectory is also consistent with an origin within the Taurid complex. This has led many researchers to conclude that the Tunguska impactor was a fragment from the Taurid swarm, a chilling demonstration of the power contained in even a modest-sized member. Some researchers also suggest a possible, though less certain, link to the Chelyabinsk meteor. On February 15, 2013, a 20-meter object exploded over Russia with the force of about half a megaton of TNT, injuring 500 people and damaging over 7,000 buildings. While its orbit doesn't perfectly align with the mainstream, it could have been part of the broader, more diffuse complex. Taking this even further, some proponents have linked the Taurids to ancient cultural shifts. Victor Klube and Bill Napier argue that encounters with the densest parts of the stream could explain events like the Late Bronze Age collapse around 1200 BCE. While these grander theories remain highly debated and on the fringes of science, they underscore the profound potential consequences if the swarm theory is correct. This unique threat, a field of numerous, relatively small but still dangerous objects, presents a special challenge for planetary defense. The goal isn't to find one doomsday rock, but to characterize an entire minefield. In 2016, NASA established the Planetary Defense Coordination Office to manage these efforts. One of our best current tools is the Zwicky Transient Facility, or ZTF, at Palomar Observatory. It scans the entire northern sky every 2 days. During a dedicated search of the Taurid swarm in 2022, ZTF found no more than a handful of objects larger than 100 meters. This is reassuring news, suggesting the risk of a civilization-ending impact from the swarm is low. However, the threat from Tunguska-sized or Chelyabinsk-sized objects remains. They are too small to be detected far from Earth with current telescopes, but large enough to cause significant regional devastation. This is where future missions become critical. The upcoming Near-Earth Object Surveyor Space Telescope, or NEO Surveyor, slated for launch by 2028, will be a game-changer. Positioned between the Earth and the Sun, it will use an infrared telescope to detect asteroids by their heat. This method is especially effective for finding dark, cometary fragments that are nearly invisible to ground-based optical telescopes. NEO Surveyor will catalog the vast majority of near-Earth objects larger than 140 meters, and many smaller ones, giving us a much more complete picture of the hazards within the Taurid complex. And this science is about to enter a critical phase. The geometry of our orbit means we are due for particularly close encounters with the swarm's core in 2032 and 2036. These events will provide an unprecedented opportunity to test the swarm theory. During these close approaches, Astronomers plan targeted surveys to confirm or deny the existence of a concentration of larger objects. The 2032 encounter is especially promising, as the swarm will approach from the night side of Earth, making any objects easier to spot. While the overall probability of an impact in these years remains low, the risk is considered to be enhanced. The primary concern is not a global catastrophe, but an increased chance of a regional event like Tunguska. As planetary defense experts have noted, if we can discover these objects with enough warning time, we can take measures to mitigate the risk. The Taurid Meteor swarm offers a profound shift in our understanding of impact hazards. The threat is not a single bullet, but a persistent, recurring shotgun blast. The slow, stately procession of fireballs across the autumn sky is a beautiful reminder of our planet's journey through a dynamic solar system. But it is also a sober warning. The ghost of a giant, long-dead comet still haunts our neighborhood. The ongoing work to understand the Taurid complex is not sensationalism, but responsible vigilance. By watching the skies and developing new technologies, we are taking the vital steps to ensure that the secrets hidden within this stream are revealed by the light of scientific discovery, not by the flash of an unforeseen impact. The Halloween fireballs are more than just a celestial show. They are a call to awareness, a prompt to look up and understand our place in the cosmic firing line.